if I'm looking at a isosceles triangle, in a isosceles triangle, there's going to be 2 equal sides and 2 equal angles. So in this case, I can see that B and C should be equivalent, and over here, E and F should be equivalent. I should also see that the lengths of A and the length of C are equivalent, and the length of D, E, and the length of D, F should be equivalent. When I measure these out, I can state that the length of this is going to be that's right. .8 centimeters, and this side is 2.8 centimeters, and the bottom happens to be 2.4 centimeters. The angles on the inside are 65 degrees, 65 degrees, and up top here is 50 degrees. For the second triangle, well, the angle inside here is 30 degrees, and the other two are 75 degrees. The length of the side lengths are 3.7 centimeters, 3.7 centimeters, and 1.9 centimeters. If we're talking about the exterior angle of a triangle, then what it's saying is if I had a triangle, I took one of its side lengths and expanded that side length out past where the triangle ends, then I'm going to wind up getting this exterior angle of a triangle, which is angle X out here. This is the exterior angle, and then the two opposite angles on the inside are going to be B and A. Those are going to be the two angles that it doesn't touch. The angle that it does touch would be angle C, and that's going to be the interior supplementary angle because X and C obviously make a straight line. So if I'm trying this out, then I'm going to say in the following examples, measure the exterior angle and the interior opposite angles. Well, here's my exterior angle. When I measure it out, it winds up being 130 degrees, and the two interior opposite angles are going to be 60 degrees and 70 degrees. For case 2, here's my exterior angle of 70 degrees, and my interior angles are going to be 45 degrees and 25 degrees. And in the last case, here's my exterior angle, and my exterior angle measures to 130 degrees, and my two interior angles are going to be 100 degrees and 30 degrees. If I am using inductive reasoning to describe the relationship I can see, well, it looks like the exterior angle is equal to the sum of the interior opposite angles. So we are going to take these skills and we're going to solve using all the things that we've learned what the different angles are going to be here. So in the first case, I know that all of the angles inside of a triangle add up to 180. If I'm solving for x, then x is just going to equal 180 minus 83 minus 65. X is equal to 32 degrees. When I go to my second example, well, I can see that A and 29 are supplementary. They add up to a straight line. So A is going to equal 180 minus 29. A happens to equal 151. I can say that B and the 36 degrees are also supplementary because they're going to be on the same straight line. And B is going to equal 180 minus 36. So B is equal to 144 degrees. I can see inside this triangle, well, this is a straight line. This angle is 90 degrees, so that angle has to be 90 degrees. Because they're right angles. If A is the exterior angle of the triangle inside here, then C plus 90 has to equal A, or 151. C is going to equal 151 minus 90, or angle C is going to be 61 degrees. The other way I could have done it, which we're going to do with D, is I know that inside of a triangle, it all has to add up to 180, like we did with the last example, which means that D should equal 180 minus 90 minus 36. So D is going to be equal to 54 degrees. If I take a look at the next set, well, I'm going to start by saying that P and 128 are going to be a straight line, which means that P is going to equal 180 minus 128, or P is going to equal 52 degrees. I'm going to say that Q and 111 are a straight line, so Q is going to equal 180 minus 111. Q is going to be equal to 69 degrees. R is going to be the third angle that exists inside this triangle. Well, if R, P, and Q all add up to a triangular 180, then R is going to equal 180 minus 69 minus 52, which means that R is going to be equivalent to 59 degrees. we can see here that S and R are on the same straight line. So S and R have to add up to 180. S is going to equal 180 minus 59. Or S is going to equal 121 degrees. And last but not least, all the angles here are going around 1 point, which means that they all have to combine to 360. So t degrees is going to equal 360 minus 71 minus 59 minus 121. T is going to equal 109 degrees. And our last example for this lesson, if I'm looking at all these points, well, here I have an exterior angle. These two make a supplementary angle. And then I can see here that this length and this length are the same, which means that this is an isosceles triangle. Well, the first thing I can do for an isosceles triangle is say if this is an isosceles triangle, then this angle has to be the same as this angle. D is going to equal 34 degrees. Angle E plus D plus 34, or angle E plus we know D is 34 plus 34 have to make up all the sides of a triangle. So I can restate that as E is equal to 180 minus 34 minus 34. Angle E is going to be 112 degrees. And because E and F make a straight line and they're supplementary, I can state that angle F is going to be 180 minus angle E, 112. Angle F is going to be 68 degrees. So, in summary, we have used inductive reasoning to suggest some angle relationships. All of the conjectures are true, and some of them will be proved using deductive reasoning later in this unit. All angles on one side of a straight line are supplementary and add up to 180. Opposite angles at a vertex are always going to be equal. Angles around a point add up to 360. Angles in a triangle add up to 180. And the exterior angle of a triangle is equal to the sum of the interior opposite angles.